Dear students, today we will discuss the Hittorf rule. If suppose we have a cell, if suppose that is a cell, it is having the negative, one end is the negative, one end is the positive, that end, negative end we denoted as the cathode electrode, positive end we denote as the anode electrode. Okay, that is one of the cell, and in this cell there is a positive and negative ions is there, positive and the negative ions is there, and when current is passed through this cell, the change in concentration of ions takes place near to the electrode. Change in concentration near to the electrode. That change in concentration is depends upon velocity of ions, migrated ions. That is given by the Hittorf's rule. First thing, we have clear that when the current is passed through the cell, the concentration near to the electrode it changes, of ions concentration near to the electrode it changes, and that change in concentration of ions is depends upon its speed or its velocity. If the speed is higher, then its change in concentration is higher. If speed is low, its change in concentration is low. If suppose we have, that is the, if we have the positive ions is there, and positive ions from this will migrate towards the left hand side, okay, to move towards the cathode side. And if its speed is the higher, okay, than the anion, okay, anion, if anion is there, anion, if it's one migrate, its 3 is migrated, its speed is 3 times is more. Cation speed is 3 times more. Then you find that the 3 ions move towards cathode and deposit, 1 ions move towards this and they give the electrons, and you found that its concentration is 3 times decreases while its concentration 1 time decreases. Okay, therefore 1 anion is decreases here, and in this case 3 cation is decreases. Therefore its cation concentration is more decreased than the anion concentration because its speed is higher, its speed is less. Therefore the change in concentration near to the electrode is depends upon speed of ions, speed of cations and the speed of anions. If suppose the speed of anions is 3 times more than the cations, then the 3 will move towards this side and only 1 will move towards this, because speed of 3 anion is 3 times more than the cation. Therefore the concentration of the anions in the cathode compartment is decrease in concentration in cathode compartment of the anion is higher than the decrease in concentration of the cation in anode compartment is less. Okay, therefore the change in concentration of cations and the anions is depends upon the velocity of the ions. Okay, that particular one thing is the Hittorf will depends upon that things. Okay, therefore the rule can be stated as if suppose the equivalent loss of equivalent cation due to migration upon, okay, at cation is migrate from, okay, cation is migrate from, that is positive charge is migrate from the anode, okay, from positive to the, okay, therefore loss of equivalent cation at anode upon loss of equivalent anion at anion migrate from the cathode due to migration is equal to transport number upon transport number of cation upon transport number of anion. Okay, that is the Hittorf's according to the Hittorf's rule. Okay, the change in concentration depends upon the and it is ultimately equal to V plus and the V minus. Okay, because we have previously seen in transference or in transport number T plus upon T minus is equal to V plus upon V minus. T plus is the transport number of cation, T minus is the transport number of anions. V plus is the migration velocity or absolute velocity of cation, V minus is the absolute velocity of anion. Okay, therefore it's also given by the loss of equivalent cation and anode due to migration upon equivalent current. Okay, equivalent current is 1, then for T plus upon 1, for the anion is the T minus upon 1. Okay, and we have known that T plus T minus is equal to 1. Okay, like that equivalent current is passed is the 1. Okay, one equivalent current is passed, then that value will be T plus upon 1. Okay, that is important thing. Loss of equivalent cation in the anode due to migration T plus upon T minus, V plus upon V minus. That is the Hittorf's rule. Okay, one thing we clear that the change in concentration at any compartment of electrode, it depends upon the velocity of ions. Okay, the two condition is there: if velocity of cation is equal to velocity of ions, and if you apply 4 Faraday electricity, you apply 4 Faraday electricity means the 4 charge is migrated. Okay, at a time total 8 charge, total 4 plus and the 4 minus is migrated. 4 Faraday electricity is applied. You found that it is negative charge. These 4 will deposited at the cathode, and by taking the electron it get deposited, and 4 minus will deposited on positive electrode and gives the electron to the this. Okay, firstly you found that its 4 is at the second stage it is having the positive, negative, no change in this case. Second, no change in this 6 positive ions is there and 2 negative ions is there, and at the center compartment there is no change in concentration takes place. Okay, 4 Faraday electricity is you applied. At the first stage 4 is migrated to the positive ions migrated to the cathode and get deposited by taking electrons, because negative means it is having the electron, negative charge is there, deposited by taking electrons, and that negative ions deposit anode by giving the electrons. Okay, at once it gives deposited by taking electrons, but anions is the deposited by giving the electrons. Okay, for Faraday electricity is applied. Okay, first stage that is happen. Second stage you found that you apply your speed of anions is the same. Okay, first thing is speed of anions is the same, and we know that for each anions to 2 Faraday electricity is applied. Okay, we applied the 2 Faraday electricity applied. Okay, by applying this 2 Faraday electricity, then your 2 positive charge migrate from this compartment to this compartment, from this compartment to this compartment. Okay, like that way 2 minus charge is migrated from left side from this compartment to, and this migrated to this compartment. Okay, this will move towards this and this 2 move to forward side. Okay, we will obtain positive, positive, positive to move this, and this will move towards this. Okay, then 4 negative charge. For this 2 positive and this migrated 2, and this will migrate to 2, and plus 2 is minus 4 charges. Plus, 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 and minus, minus. Okay, when the speed of the ions is the same, then the change in cation in a anodic compartment is the same as the change in the anion in the cathodic compartment. Okay, we have divided the that cell into 3 parts. The center part is the 2 parallel lines, imaginary lines we have put it there. Therefore, it divided the cells into 3 compartments: center compartment, cathodic compartment, and this is the anodic compartment. Okay. First, we have seen the speed of anions and the speed of cations is the same. Okay, therefore 2 cations move and 2 cations move, and 4. Okay, totally 8 charges is moves. Okay, therefore we have applied the 2 Faraday's electricity for this and 2 Faraday's for negative ions. Okay, move toward this. Okay, therefore speed is same, therefore 2 is move, 2 anions move, 2 anions is move. If speed is the different, if suppose speed of anions is more than the speed of cations, 3 times more. Okay, first okay, like that. Second case we have to see. Okay, first case, the second compartment is the same thing is happened. Okay, we apply the 4 Faraday. First, it immediately deposits because concentration is more, and positive negative is very near to cathode and the anode. Therefore, it immediately deposited, and the first case is the same. Result obtained in the same speed and result obtained different speed are the same. We know that the speed of the cation is the less than 3 times less than anion. Okay, therefore the one cation move towards it. Okay, if one cation move towards forward side, then the 3 cations move from the cathodic compartment to this side. 3 moves to this side, and next steps we will obtain. There is a 5 cations and the 5 anions. No change in the center compartment. Positive, 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 negative, negative, negative. Okay, so like that situation is obtained. Okay, therefore, in this case, you found that change in anion in a cathodic compartment. And when you compare, okay, in this case at the start it was 6, therefore 3 is less, minus ion is there. Change in the cation in the anodic compartment, change in the positive in anodic compartment is 1. Okay, therefore change in the anion, okay, 3 change in this case. At the first it was 6, after that 5 positive is there, 1 positive is changed, and in this case 3 negative is changed. Therefore change in anion in a cathodic compartment is 3 times more than the change in the cation in anodic compartment. Okay, like that way we prove that. Here we prove your the change in concentration at anodic compartment or respect to electrode is depends upon the velocity. Okay, this is all about the Hittorf rule. I hope you get the idea about the Hittorf rule, what is meaning of Hittorf rule. Thank you very much.